do have a do now for you, so go ahead. My directions are to simplify, and I'm going to have just one problem. 2 over 3 plus I, that whole quotient squared. Alright, who thinks they have an answer? Who thinks they have an answer here? Simplified form.
2 times 4 minus 3I over 25.
Yep, I distributed in that too, so we're at 8 minus 6I over 25. But both answers are the same, just written in a different way. Anybody need to see me do this? Okay, let's do it. So it really didn't matter where you started here, but just to follow sort of the advice I gave you last class, my advice was to always sort of rationalize first and then go from there. But even if you didn't rationalize first in this specific scenario, it wouldn't have made a difference to you. But I would just have followed that advice I gave. So here we have 2 over 3 plus I, and we're going to obviously end up having to square it. But to rationalize the denominator, because it's a binomial, I have to multiply by its what? Conjugate. So I'm going to multiply by 3 minus I, top and bottom. Now remember, when we're dealing with complex numbers and you multiply by the conjugate, it's going to be not a squared minus b squared. It's going to end up being a squared plus b squared. So you want to remember that a plus bi times a minus bi gives us a squared plus b squared. That was what you had to remember here. So in our denominator, I'm going to get my a squared, which is 9. My b is not I. My b is the coefficient of I. What's the coefficient of I here? 1. So 3 squared plus 1 squared. That gives us 9 plus 1, which is 10. And then we're going to have 2 times the quantity of 3 minus I in the numerator, and we square that. So here we're at 2 times the quantity of 3 minus I over 10, that whole thing squared. But can I simplify the 2 and the 10, which gives us 5 in the denominator? So now I'm left with 3 minus I over 5. I'm going to square the numerator. I'm going to square the denominator. In our denominator, we get 25. In our numerator, can I just distribute and get 9 minus 1? Do I do that? No, I don't just distribute in that exponent. What do I have to do here? FOIL it out. So you're going to get 3 times 3 is 9. 3 times negative I is a negative 3I. Negative I times 3 is a negative 3I. Negative I times negative I is a positive I squared. So here we're going to have 9 minus 6I minus 1. 9 minus 1 is 8, so we're at 8 minus 6I. Now, Arsh saw that he can pull out a GCF in the numerator. You can pull out a GCF, but it doesn't simplify with the denominator, so there was really, it wouldn't have been helpful to us. All right, we ready for today's lesson? So yesterday, we spoke about I raised to different exponents. So let's just recap what we wrote yesterday, or what we spoke about yesterday. I to the first power is just I. What about I to the second power? What did we say that was? Negative 1. What about I to the third power? What did we say that was? Negative I. And I to the fourth power? 1. Do you think you have to memorize this? Yes, you must memorize. All right, so now we're going to take it to the higher powers of 4. Higher than 4. So there is a shortcut. Let's see how many we need to do before the majority of you catch on to the shortcut. So let's say, my first example, let's say I have I to the 5th power. Well, we know I to the 5th power is I times I times I times I times I. But what do we know every 4 i's multiplied together make? A 1. So then we're just left with 1 times I, which is I. Okay, what about I to the 6th power? Well, that's I times I times I times I times I times I. But what do we know about every 4 i's? Every 4 i's make 1. So we're left with 1 times I to the 2nd power. But what's I to the 2nd power? Negative 1. So I to the 6th power is negative 1. Who thinks they see the shortcut here? Okay, if you see the shortcut, what would I to the 7th power be? David?
I to the 7th, wouldn't that be negative I?
Negative I, you got it. Who thinks they see the shortcut here? Navya, if you see the shortcut, what would I to the 25th power be? Negative 1.
Or no, just I.
Just I. All right, what is the shortcut, guys? What is the shortcut? Simon?
Whatever the remainder is what you just calculate for.
Exactly. You divide the exponent by 4. Why? Because we know every 4 i's make 1. So what we did here was we were going to take 25 and we're going to turn that sort of into a multiple of 4. So what does that mean? We can change I to the 25th power into I to the 24th times I to the 1st, right? Or you can look at it as 25, 4 goes into 25 6 times with a remainder of 1, which means there's just 1 I left over. It's all the same way, no matter how you look at it. Turn it into a multiple of 24, or you just divide by, turn it into a multiple of 4 or divide by 4, same process. So if you see the shortcut, how would we do I to the 27th power? If you see the shortcut, what would we do with I to the 27th power?
You have like a remainder of 3, so then it would just be negative I.
You got it. So if you took 27 and you divided it by 4, 4 goes into 27 6 times. 6 times 4 is 24. You would have a remainder of 3. So that means our remainder would be I to the 3rd, which is, if we had it memorized, what's I to the 3rd power? Negative I. You got it. All right. If you see the shortcut, or if you're catching on, what would I to the 46th power be? What would I to the 46th power be? You got it. It would be negative 1. Are we all good here? Anybody not understand how to simplify these? Okay. So let's do more problems. My directions are to simplify. So I have 1 over 2i plus 1 over 3i squared plus 1 over 4i cubed. Okay, is this an equation? No. Since it's not an equation, am I allowed to eliminate the denominator? No, we cannot eliminate the denominator. I am going to have to create a common denominator, but before I create a common denominator, what must I do first? David? We must rationalize it. Even before I rationalize it, what do you realize we can even do for some of them? Simplify, exactly. So the 1 over 2i will stay 1 over 2i. But what about 1 over 3i squared? Isn't that just going to become negative 3? Because I squared is a negative 1. Hey, what about 1 over 4i cubed? What does that simplify down to? Say it one more time. You got it. 1 over negative 4i. All right, so now, before I create a common denominator, what must I do? What David told us? Rationalize. These are just monomials. Because they're just monomials, what do I have to multiply by to rationalize? Just I. Because these are just monomials, I just have to multiply by I. So multiply by I in the first one, and I end up with I over negative 2. I do not need to rationalize negative 1 over 3. And for the last one, again, I'm just multiplying by I, and I'm going to be left with I over positive 4. How come I got positive 4, not negative 4? Matt? Perfect, because we originally had a negative 4 in the denominator. I squared is negative 1. So it's negative 4 times a negative 1, which gives us that positive 4. Okay, so I am now going to assign all the negatives to the numerators if I have. So I have negative I over 2 minus 1 over 3 plus I over 4. Are we now ready to make a common denominator? Absolutely. 2, 3, 4. What is the common denominator? 12. So for the first fraction, I will multiply numerator and denominator by 6. So we're at negative 6i in our numerator. For the second fraction, I'm going to multiply numerator and denominator by 4. So we're at a negative 4 over 12. And the last one, I'm going to multiply numerator and denominator by 3. So we're at plus 3i over 12. Now that we have a common denominator, now I can leave the denominator and add the numerators. So I have a negative 6i and a positive 3i gives us a negative 3i, and then we just have our minus 4. It does not matter if you want to write negative 4 minus 3i or negative 3i minus 4. It's all the same. All right, next one. All right, so I have I root 3 raised to the 4th power. Inside the parentheses, is it a monomial or a binomial or bigger? What is it? Matt? It's a monomial. So what does that mean for us since there's no plus or minus signs?
We just multiply each thing inside it to the 4th power.
Good. We can just sort of distribute that power of 4. So this is going to be I to the 4th power and root 3 to the 4th power. So what is I to the 4th power? 1. Root 3 to the 4th power is root 3 times root 3 times root 3 times root 3. But what's root 3 times root 3? 3. Again, root 3 times root 3 is 3. 3 times 3 is 9. All right, next one. I'm going to have you do 1 plus I raised to the 2nd power. I want you to figure that out on your own. What is it? What's the quantity of 1 plus I raised to the 2nd power, right? 2i. I want you to memorize that. Not that you have to, but I want you to know that because it's going to help in like the next problem we're going to do, and it will save you some time on the test. If you remember that the quantity of 1 plus I raised to the 2nd power will always be 2i, when I raise it to higher powers, it's going to make life a lot easier. Let me show you. So here, if we memorize that the 1 plus I raised to the 2nd power will simplify down to 2i. If I give you 1 plus I raised to the 6th power, we can change the format of this because do you think foiling out this thing 6 times would be fun? No, it would not be fun. But if you know that I have the quantity of 1 plus I, and we already know what 1 plus I to the 2nd power is, and it's just a monomial, right? I can change that exponent into a power raised to a power. So I can make this 1 plus I to this raised to the 2nd power raised to what power? To make it the 6th power. 3, right? Power to a power, don't we multiply? So I didn't really change the value, I just sort of wrote it in a different format. Why? Because if we had it memorized that 1 plus I to the 2nd power is 2i, then we're just going to have 2i to the 3rd power, and since it's just a monomial, what can I do? Just sort of distribute that in, right? So this is going to be 2 to the 3rd power and I to the 3rd power. 2 to the 3rd power is 8. What's I to the 3rd power? Negative I. So we're at a negative 8i. Makes life a little bit easier, right? All right, next one. What number was this? Did I stop numbering them? This was 4. Okay. I want us to show that 1 plus I is a fourth root of negative 4. Okay, what does that mean? That I need us to show that 1 plus I is a fourth root of negative 4. Ready? Okay, well, doesn't that mean the fourth root means I take literally the fourth root of negative 4? And they're saying if I take the fourth root of negative 4, what should it equal? 1 plus I, which is the same as saying if I do 1 plus I to the fourth power, what should that equal? Negative 4. Do y'all see that? So I need to show this, that 1 plus I to the fourth power is negative 4. But we're dealing with 1 plus I again, right? So can I change this to make this a little bit easier for me? The 1 plus I raised to the fourth power, what do you think I'm going to change that into? 1 plus I to the second raised to the second. Why? Why did I do that? All right, she's holding up the class. Your back must hurt today. Somebody else. David.
Because if you get 2I and you square it, you'll end up with negative 4.
You got it. Because it makes it easier, right? We already memorized, or I told you to memorize, that 1 plus I raised to the second power is 2I. So we can simplify this down to 2I. And then when we have 2I raised to the second power, isn't that going to be 4I squared? We need to keep showing that this is negative 4. Well, 4I squared, isn't that negative 4? So we showed that it was the fourth root. All right. Next set of directions are to solve for x. So if I have x plus 2ix minus 4 equals 0. Can we factor this? Can we factor? I'm going to say no. Even though I want to say yes, I'm going to say no. Why are we not able to factor this? Ariana? Good. Usually when it's some kind of format to be factored, I have one exponent and then the other exponent is half of the first exponent, right? Or one exponent is double the other exponent. In this scenario, what do we realize? Both exponents are the same. So this is not something that we can factor. We're just solving for x. So what am I going to do? I'm going to get everything with an x term on the left side. Anything that doesn't have an x term on the other side, I'm going to add over that 4. So now I have x plus 2ix equals 4. What do you think I'm going to do on the left side? Good. I'm going to pull out a GCF of x. When I pull out a GCF of x, I'm left with 1 plus 2I. And remember, we're solving for x. If I'm solving for x, what should I do now? Divide by 1 plus 2I. So then I end up with x is equal to 4 over 1 plus 2I. Am I allowed to leave it like this? No, right? There's an I in the denominator. That's the square root. That's a radical in the denominator. We can't leave that. So what do I have to multiply by? The conjugate, 1 minus 2I. Now remember, when you have a plus bi times a minus bi, our product is not a squared minus b squared. What's our product? A squared plus b squared. So we're going to end up with x is equal to 4 times the quantity of 1 minus 2i over a squared is 1. Our b squared is 4. So we're going to end up with x equals 4 times the quantity of 1 minus 2i over 5. You can leave it like this. You can distribute it in. I don't really care. And here we are. All right, next one. Again, we're still solving for x. Is this something that can be factored or attempt to factor? Yeah, how do we know this is something we can try to factor? Because we have an x squared and then an x to the first. All right, now remember, when we're factoring, we need factors of the last number that add to the middle coefficient. Do we agree? But the only way to add to I is if both factors have what in it? An I. The only way to add to an I is if both factors have an I in it. So when we come to break down, we know that we need an I and an I, right? I'll write it over to the side. We need an I and an I. Well, what's I times I? I squared, which is really what? -1, right? So to make this 6 into an I, it's going to have to be -6I squared without changing the value, right? Because I squared is -1. -1 times -6 gives us that +6. So this is how I can write 6 with an I without changing its value. Are we all okay with that? So now we need to come up with the factors here. So we know the factors have to be an I and an I. Each factor has to have an I in it. And we know an I times an I is -1. So now we're going to say -1 times what number? -1 times what number will give us this -6? But also add to 5. Okay. Say it one.
Oh, wait, sorry,
6i and a -1i. All right, let's check this out. 6i times -1i is a -6i squared, which is a +6. Are we good there? Yeah. And then we're going to have 6i plus -1i. Isn't that a 5i? Are we good there? Yeah. So then we come to factor, and we're going to have x plus 6i, x minus I, all equals 0. Then we solve. X plus 6i equals 0, x minus I equals 0. So we get x equals -6i, that's one answer, and x equals I, that's another answer. All right, do you guys want to try one of these on your own? All right, try this next one on your own. X squared plus 2ix plus 3 equals 0. Again, I want you to solve for x. Yeah.
Any extraneous solutions within this?
For the factoring?
Yeah.
No, you're not checking for any extraneous solutions for factoring. The only time I need you to check for extraneous solutions is if I physically put a radical in the problem. with a variable. So a radical with a variable, that's when we check for extraneous solutions. Okay, so what should we have done here? For this one, in order to add to an I, we know both factors have to have an I in it. So I'm going to change that 3, positive 3, into a negative 3I squared. So still keeping it a 3, just writing it in a different format. So now we're going to take that negative 3I squared and we're going to say, okay, well, the factors each have to have an I in it. So the I squared splits into I times I. Then we need what multiplies to negative 3 but adds to a positive 2. What multiplies to a negative 3 and adds to a positive 2? Positive 3 and negative 1. So now we double check this. 3I times negative 3 times negative 1I is a negative 3I squared, which is a positive 3. We're good. 3I minus I is a 2I. We're good there. So now our factors, x plus 3I, x minus I equals 0. So we get x is equal to negative 3I, and we get x is equal to I. All right. Ready for this last one? Last problem. This is not an index, that's just a 5. I know, because I didn't want you guys to think it was an index. Okay, I need some thoughts here. All right, so I'm looking at what we have. I have x over x plus 1. That whole quantity is raised to the first power, right? But then I have 5 times the root of x over x minus 1, which means this whole quantity is raised to what power if it's the square root? A half power. So what do I have? I have some base raised to the first power, and then don't I have the same base again raised to the half power? So I have one base to the first power, the other base raised to the half power. Generally speaking, when you have one base doubling the other one, when it's the same base, so one exponent is double the other exponent, what can we do? We can generally factor. In this scenario, it doesn't look very nice, right? So what can I do to make this look a little bit nicer since I have the same base?
Substitute.
We can use substitution. So I'm going to let m equal x over x minus 1 to the half power. So then I'm going to have m squared minus 5m equals 6. What should I do now? Good, move the 6 to the left side and then we can factor. So we have m minus 6, m plus 1, and then we end up with m is equal to 6 and m is equal to negative 1. Are these my answers? No, the biggest thing with substitution that most people forget is to substitute back, right? So now I know that m is not m. M is representing the root of x over x minus 1 equals 6. And then you have the root of x over x minus 1 equals negative 1. I'm going to just focus on the left side right now. We'll talk about the right side in a minute. Let's focus on the left side. We know how to solve this. How do we solve it? Square both sides. You got it. So we're going to square both sides. So now I'm going to have x over x minus 1 equals 36. I'm going to cross multiply here. So then we're going to end up with 36 times the quantity of x minus 1 equals x. Distribute in. So 36x minus 36 equals x. I'll subtract the x and move the 36 over to keep it all positive. So we'll have 35x equals 36. So x will equal 36 over 35. That's 1. Right, right off the bat, something should stand out to us. What should stand out to us? The negative 1, okay? Right there, I know I'm going to get a no solution, but let's say you didn't realize that. Let's say you just kept going with this. If you kept going with this, you're going to end up squaring both sides. So you're going to get x over x minus 1 equals 1. Then you would cross multiply and you get x minus 1 equals x. When you subtracted that x over, you'd get negative 1 is equal to 0. Is that a true statement? No, so even there you'd realize this is a no solution here. Okay, this was a radical with variables inside. Because there was a radical with variables inside, what would you have to check for? Extraneous solutions. I will tell you this does work out. Do you want to see me do the check? No? We're good? You trust me? Okay. Check works. All right, we're done for today. Your homework is a worksheet.